Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video, I want to talk about the identity matrix. And I want to just briefly go over what an identity matrix is and how we can construct one for a matrix of a given dimension. So the identity matrix, again, as I said, was the matrix equivalent of the number 1. So let's go ahead and talk more about what we mean when we say the identity matrix. Okay. And so what I want to do is I want to start off by sort of setting up a definition of what we mean mathematically with the number 1. Right? The math of the number 1. So this is not a proof by any means. This is just sort of a definition that I think we all intuitively know because we've learned our times tables, but you may have never heard it or you may have forgotten the sort of explicit definition of this. So let's say we have a number A, right? And A, right, in matrix, since we're dealing with matrix algebra, this is a scalar, right? But again, a scalar in math is just any number, right? So this is any number. It could be 3, it could be pi, it could be a half, it could be negative root 2, or it could be any number you can think of, right? If we do multiplication, right, multiplication, and then we have this thing that we call 1, which in our sort of base 10 counting system, right, we use this symbol here. This is a symbol that represents 1. I know that's kind of an abstract concept, but this is just the number 1, right? The number 1, right? Any number times 1 gives you, right, that same number. Right, this is sort of the mathematical definition of what it means to be 1, right? This thing times any number gives you that same number, okay? So this is in normal math, right? This is dealing with scalars. Well, what does it mean to do that with matrices, right? The matrix equivalent. What is the matrix equivalency of this idea of the number 1? Well, let's replace our A here with a capital A, right? So now, because this is capitalized, again, based on our notation, right, this is a matrix. I'm going to scroll down just a little bit. Right, this is a matrix. Specifically, though, this is a square matrix. I'm going to underline square here because the square part is very, very, very important. Right? This square here is very important. We cannot do this if A is not square. Okay, again, we cannot, this whole concept falls apart if A is not square. What does it mean to be square? Just to make sure we're on the same page here, right? If you remember back to the dimensions of a matrix, we said that a matrix was an m by n, right? M rows by n columns. For a matrix to be square, it must have the same number of rows as columns. Right? It must have the same number of rows and columns. Right? That's what it means to be square. Okay, so in our mathematical definition of 1, right, any number times this thing we call 1 gives us back that same number. So let's go ahead and apply this concept to our matrix equivalent, right? We have a square matrix, again, square being key here, multiplied by something. So we'll put the multiplication here, right? Multiplied by something, and I'm gonna leave that empty for now. In order for it to be equivalent to this idea of 1, when we do this multiplication, we have to get back, right, that same number. Or sorry, that same thing. Right, so in order for this to be the matrix equivalency of 1, we have to multiply our square matrix here by something that'll give us back that same thing. Otherwise, we've changed it and it doesn't match our definition here. So what I'm going to do for now is I'm going to throw in a placeholder, and I'm going to put the placeholder called I. Right, this I, right, this is what we call the identity matrix. Okay. Now, I'm not going to go through the proof behind how we get the identity matrix. I'm just simply going to sort of go from this idea that the identity matrix fills this void where if we multiply a square matrix by its identity matrix, we get back that same square matrix. Right? So hopefully you understand what the identity matrix is supposed to do. So let's go ahead and give ourselves a little bit of room here. And let's talk about what the identity matrix looks like. You know what? We're actually going to leave it off with what does an identity matrix look like. We're going to pick this up in the next video where we're going to walk through a very quick, simple 2x2 example to show you what an identity matrix looks like, and then we can generalize that to larger matrices. So hopefully everything we talked about up to this point made sense. The idea that an identity matrix is just the matrix equivalent of 1, and that means that we have some square matrix multiplied by this thing that we called I will give us back that same square matrix. And as always, if you have any questions, please reach out. Thank you.